Right, our next topic now is on inflation. Inflation is a term that describes the continuous upward movement in the general level of prices. Okay, so let's just have a bit of a revision of what happened in the 1970s in Australia. Inflation rates were very high in Australia and they were around about 16-17% throughout that time. But over the past few years, it's been quite low and around about 2.5%.
Oh, variables about
inflation
4
rate.
or 5. Yeah.
Yeah, so it's been okay for the last few years. So let's see what happens and how we work this out. Okay, let's have a look at an example. Suppose that the inflation is recorded at 2.7% in 2006 and 3.5% in 2007. And that a loaf of bread costs $2.20 at the end of 2005. If the price of bread increases with inflation, what will be the price of the loaf at the end of 2007? Okay, so guys, what I want you to think about is this. We're saying that it's increasing. Now, there's two ways to do this, but the quickest way I'm going to show you in a sec. Now, what we're saying is, a loaf of bread costs $2.20 at the end of 2005, and it's gone up by 2.7% for 2006. So I've got to increase this. So an increase, so usually what you would do is go 2.7 divided by 100 times $2.20, get that answer and add it back to the $2.20, and that's the new price of the loaf of bread. But to do this all in one hit, all you have to do is write down $2.20 plus the
Not $2. You go $2.20.
$2.20 plus,
and we're going to times
an increase of
that
102.7%.
Because our increase is 2.7%, and our bread costed 100% originally. So the end of 2005. So full price will be 102.7%.
So we want to increase it by that. So all you do is go $2.20 times 102.7 divided by 100, and that will give us the answer in one hit, and it'll be $2.26. And that's the way you do that in one hit. But like I said to you before, you can do it the other way as well. So now, if at the end of 2006 the price of the bread was $2.26 and it increased again to 3.5% up, so we do the same thing in one hit on your calculator as well here, and then you can just write down that $2.26 plus 100% of that price is $2.26, 3.5% on top of that, so 103.5, right? So you multiply $2.26 times 103.5%, which is divided by 100, and that will then give you the new price. So that's about 8 cents, and they give you the new price of $2.34, right? So that's how that works on the price of inflation. Now, let's have a look over a larger period of time. So let's have a go. Suppose that a 1 litre carton of milk costs $1.70 today. What will be the price of 1 litre of milk in 20 years' time if the average annual inflation is 2.1%? Now, for 20 years, this is just an example, okay? So they're saying on average, so it could be 2.7 one year, 1.5 another year, 2.5 another year, 2.3 another year. However, average over 20. So we're just assuming here. So our average in this question is quite low. We hope that we could keep it at 2.1% for 20 years, but likeliness, Mr. D, I don't think it will happen. But just to answer this question over a longer period of time. Now, this is pretty much the same as compound interest, isn't it?
That's right, because remember, you've got to add it on for the next 20 years. You don't want to work out first year, second year, third year 20 times, because the interest rate is the same. It's an inflation, but it's still a rate.
Okay, so now you can do this in Solver, or you can do it by hand, whatever you like, but I think we should just use Solver for this. So, but the actual formula, guys, if you remember, was AN equals P multiplied by 1 plus R on 100 all to the power of N. Okay, so you know this, or to the power of T, whatever your teacher decided to use with you. It does not matter, so just as long as you get the answer right. And if you're putting that into the calculator as well, you'd put the whole formula in and then in comma, and then AN if you want to find that amount. So, in this situation, our principal amount is $1.70 because that's the price of the milk. Our rate is 2.1. Okay, so you can put that into solver as well. And it's our N, our number of years is 20 years. And you put it into the solver and you get an answer of $2.58. That's 20 years for the N. And once you put it into solver, you'll just get your answer in one hit as $2.58.
Sorry, so it's 20 years for the time, but it's one time.
Oh, you're using that formula, yeah.
1 year
Okay, that's
every
fine.
time, so N is
Just
1.
make sure you know which formula you are using.
So when we solve, we put in A, because that's what we're trying to find, price of the milk in 20 years' time. We've got $1.70
in there.
and we've got 1 plus our R, 2.1. Now I'm not going to be bothered dividing by N because N is 1. So I'll just do divide by 100.
That's right.
And again, N is 1, so I'm not going to put 1 times 20. That just equals 20, so I'll just put that into my calculator. Then, of course, you put your comma because you're solving for which letter? A. And in 20 years' time, when you hit enter, you get A equals
$2.58 to the nearest cent. That's what they wanted.
$2.58. Remember here, we do not round to 60 cents or 55, just like we're used to when we're going to buy stuff. We leave it as it is.
Okay, now part B is exactly the same situation, except the interest rate is more, I think, appropriate for us.
That's right.
Right,
I
which
think
is,
so too.
they're saying here about 6.8% on average. Maybe, you know, we don't know, we can't predict the future, but on average, if it was 6.8%, I don't think you have to write it down, Mr. Dinatale, because you've got it up the top there.
No,
So
I'll just write that the interest rate is what's changing, so instead of 2.1, it's a 6.8.
you
So
just
on
plug
your
in.
calculator, it's exactly the same steps, and we get an answer of
you get an answer of $6.34. And that's, I think, a more realistic figure, because
That's
our
right.
farmers will be struggling if it stayed at 2.1% anyway.
That's right, I agree.
Prices are always going up, and that's the general trend of inflation. Yep. Right, the last bit in this section is called purchasing power. Now, this time we'll be looking at keeping money hidden at home or somewhere else and see what it is really worth in the future, because we know, I've heard of stories of the oldies hiding money under the mattress. They've got $100,000, they put it in a mattress, and
that's a good example. We'll use the 100,000 as the example here.
I'd be lucky to have 100,000 in a mattress.
But in 20 years' time, or 30 years' time, or
What's
50
it
years'
worth?
time, is it going to be worth $100,000?
I don't think so.
In theory, you would think so. But $100,000 now, compared to 30 years' time, the way prices are going up, it won't be. But let's have a look at one.
Okay. If savings of there you go, there's a
There we
question.
go.
100,000 are hidden in a mattress in 2006, what will be the purchasing power of this amount in 8 years' time if the average inflation rate over this period is 3.7%? So, we've got our interest rate of 3.7. Our N is 1. Why is it 1? Because
Once every year is what the inflation rate changes, isn't it? Goes up, inflation goes up once a year.
that's right. Time
Time.
is going to be for 8 years.
Lucky they give it to us as a number instead of a word.
And our A is 100,000.
A is 100,000. That's what we've
That's
got.
what's in there at the moment. So we're trying to find the principal amount
That's right.
after that time.
So again, we're going to put this straight into solve.
So it's really still the compound interest formula, isn't it?
That's right, compound interest formula. And we're not going to write the formula this time. We're just going to fill it in. So we've got 100,000 because it's A.
Because mathematicians are lazy, aren't they? But
They are lazy. Very smart people though.
Students can't.
P bracket
1
plus R, which we know is 3.7, divided by N, which is 1. I'm not even going to do that. So divided by 100 times the power of N, which is 1t, and 1 times 8 is just 8, so I'm going to leave it like that.
And guess what, Mr. Dinatale?
And we're solving for?
We're solving for P.
We're solving for P. Close our bracket, and we end up getting that $100,000 in 20 years' time, sir, please be gentle, is worth how much?
$74,777.33.
So guys, is it worth keeping your money under your bed or hidden in your sock drawer or left in your wallet?
I don't think so. However, Is it worth putting it into a bank account? Maybe, but guess what happens, guys? You get taxed on the money from the government.
But that's fine, because at the end of the day, even at 50% that you're giving to the government, if you make $2,000, you pay 50%, $1,000 goes to the government, you've still got $1,000 in your pocket. You still end up getting money out of it.
I agree with you. You still make money. However, I'd put it still in investment. I'd put it in property.
An investment, property,
because it might work out a little bit better than putting it in the bank, because they'll just take most of it anyway.
That's right.
All right, the next part, guys, that's it, I think, for this unit.
So, yeah, looks like that's it,
exercise 21D. Do all the questions there, and we'll